Okay, again, we're talking about the rate at which temperature changes being related to temperature difference, the difference between room temperature and washer temperature. The closer the washer gets to room temperature, the less the temperature difference is, and the less we expect the rate of change to be. And our graph, with its decreasing slope, represents that fact. Now, what do we mean by the rate of temperature change? Well, the rate of temperature change is the change in temperature divided by the change in clock time. In other words, the slope of this graph, the delta y divided by the delta t that we get between 2 points of the graph, is going to give us our average rate of temperature change, just as this rate of change, the delta y over delta t, for a depth function gives us the rate at which depth is changing, or the speed of the water surface. In the limit, we get the slope of the tangent line, and we call that d big T, d little t. We can call it dt, dt, as long as we understand that the first t is big, the second t is little. First t represents temperature, second t represents time. So that the rate of temperature change is going to be represented by dt, dt, d big T, d little t. The temperature difference is nothing but the temperature of the washer minus the temperature of the room, or T minus TR. So that temperature difference is T minus TR. So in symbols, we can phrase our question as, how is the rate dt, dt, d big T, d little t, related to the temperature difference T minus T sub r? Do we expect this rate to be linearly related, to be proportional, proportional to the square root, inversely proportional? Do we expect some kind of proportion between these? Or do we expect some other kind of relationship? Let's look back here again. Okay, our d big T, d little t is going to be the slope of this. It's going to be how steeply the graph changes. And our T minus TR is going to be the difference here. And we see that the closer this curve gets to its asymptote, temperature T sub r, the less slope it has. This suggests that there might be some kind of proportionality, maybe a direct proportionality, but direct proportionalities don't always occur when we expect them to. Maybe proportionality to the square or the square root, as mentioned before. So those are the questions we're going to look at next.